Right, so I had to pause the previous video because it was getting a bit too long. So I'll explain what I've written here in a second. Before that, let me remind you that this was a definite integration from 0 to 1. I forgot to mention that earlier. So else it would have been a problem because it will be a non-ending series. Here, what's the good thing is that if you put 1, log 1 is 0, so this term becomes 0 in the upper limit. Now, if you put x equal to 0, that's a lower limit. That's again, x. If you put it as 0, the whole term again becomes 0. So, so the neat part about this is that all of these terms, they actually become 0. All of the terms that do have log x, will give you 0, because if you put 1 there, it will give you log 1, and that is 0. So you need to find out which term of this whole expression has no log in it. So for that, if I write down the rth term, the log expression for the rth term, it will be like this. That is log x raised to n minus r minus 1. You can kind of deduce this logically. This is the logical part of this problem, actually. If we put r is equal to 1 here, then it becomes 1 minus 1, 0, log x raised to n. That's the first term. R is equal to 2 here, then n minus 1, that is this thing, and so on and so forth. So for this thing to be equivalent to 1, this whole term to be equivalent to 1, well, the exponent should be equal to 0. So that means the term is going to be the n plus 1th term. So in other words, we actually got which term that we need. All right. So here you can see that the sign of this integral, it oscillates between, well, alternates, I should say, not oscillates, negative, positive, negative, positive, and so on and so forth. And since this summation initially the n it goes from let me take you back here. N, we know it goes from 0 to infinity. So I can write this as minus 1 the whole raised to n. The first term, it will be n equal to 0. And then it will be positive, positive, negative, and so on and so forth. So it'll be like this, minus 1 the whole raised to n. Then this thing, like I said, this term will become, well, 0. The exponent will become 0, and yeah, that means that this whole expression will equate to 1. And if you put x equal to 1 there, then this part becomes 1. And the numerator, you can see here, it goes like this: n minus 1, n minus 2, so on and so forth. And it will be, you can see that when it was the first term, there was no such thing. When it was the second term, it was just n. Then for the second term, it was, third term, it was n minus 1. So for this is going to be the n plus 1th term, so it'll just be 1 here. Now that whole divided by, first term there was an n plus 1, second term there was n plus 1 squared. So for the n plus 1th term, there will be n plus 1 the whole raised to n plus 1. Or in other words, and the lower limit, as you can already guess, is 0, because if you put x is equal to 0 in any of this, all of these terms are going to have this, right? So any of this, the lower limit is going to be equivalent to 0. So this is equal to minus 1 the whole raised to n into n factorial the whole divided by n plus 1 the whole raised to n plus 1. So this, my friends, is the I double dash, right? It's a bit chaotic here, but I hope you understood. Let me repeat it once again. The general format for any term in this series is going to be like this: x raised to n plus 1, we saw it from here, right? The x raised to n plus 1 term is going to be there, divided by n plus 1 is going to be multiplied every single time you progress in the series. Log x, its powers will decrease 1 by 1. So that will be the general form of the series. And the thing is, the good part about this is that if you put x equal to 1 here, the upper limit of any of these terms that contain this log x will yield a 0. And because these terms also contain something, a polynomial with x, if you put x equal to 0, that is the lower limit of this integral, that will also lead you 0. So what's the good thing about this is that all of these preceding terms that do contain both x and log x will lead to 0. So we need the term that does not have the log x, because we know this x raised to n plus 1 term is never going to disappear. The only term that's going to disappear is the log x term. So we found out that term by writing down the general form of the exponent of the log x function, and then we figured out which term it is, and then we figured out what the form of the n plus 1th term of this integral will be, and yeah, we wrote it down like this. Now we can finally substitute back here. So I dash was just 1 by n factorial into I double dash, which is 1 by n factorial into minus 1 the whole raised to n into n factorial divided by n plus 1 the whole raised to n plus 1. Now look at that. The n plus 1, sorry, n factorial, they get neatly canceled out there. So what was I dash again? Let me flip the pages here to remind you what it was. It was in a summation, right? So sigma n equal to 0 to infinity. What did we get this I dash to be? We got it to be minus 1 the whole raised to n divided by n plus 1 the whole raised to n plus 1, right? So this is not I double dash. This is simply I dash. Okay? Yeah, it is I double dash. What am I saying? My God. Okay, so yeah, minus 1 the whole raised to n divided by, if I substitute this, let me just write it here. Minus 1 the whole raised to n divided by n plus 1 the whole raised to n plus 1. So here, what you need to do is just simply write that down. The summation of this is going to be your answer to this integral right over here. Now, it was a bit troublesome because we did not use the gamma function. Now, I think it's going to be a bit more easier if you do it that way, I guess. But if you don't have any idea what to do with the gamma function, how to apply the gamma function, always remember that logic is where it is also derived from. So yeah, you can do it that way as well. So I hope you understood it. I think it got a bit confusing towards this point. So that's why I had to repeat it once again. So if you got any doubts, I guess you can leave them down in the comment section. I will try to clarify them. And yeah, I hope you understood how we can, proceed with this problem. Okay, thank you.